Accordingly, at the Ecole Polytechnique, the focus was on theory first, application later, with mathematics at the absolute core. For example, one of the founders was Gaspard Monge, developer of the descriptive geometry. Descriptive geometry is the theory of three-dimensional bodies that underlies contemporary practices of mechanical drawing, including those still found in software packages such as AutoCAD or CAD-Key. The French engineer Claudius Crozet brought descriptive geometry to the United States when he took a teaching position at West Point, after which he became principal engineer of Virginia and founder of the Virginia Military Institute, organizing institution in a French model. Monge himself had been educated under the old regime at the elite military school, military engineering school. And he served as professor at the Ecole Polytechnique for 10 years. As the historian Wolfhard Weber explains, Monge's desire was to contribute through mathematical theory to the development of the new French nation state. And I'm going to quote him here at some length. Quote, Monge himself insisted that descriptive geometry was an answer to the French nation's requirements. He said that this science had two aims. First, it would make it possible to represent three-dimensional objects in two dimensions, which was, of course, most important to designers. In other words, this representation of three-dimensional objects in two dimensions would enable society to apprehend order in nature and then apply it. Second, Monge could fix the exact site of objects and of their several parts and how they fit together. In this way, he brought together a series of factors fundamental for, as he put it, progress. In other words, to be able to represent order in nature, in order to be able to control it, you had to be able to understand how objects stood in relationship to one another. Continuing the quote. He advocated rationalization of the work process by strict observance of the prescription, by execution of scientific knowledge, by quantification, and by the introduction of machines. End quote. So can you sense here, can you feel the optimism for using mathematics to found a more rational organization of society? Consider now some other examples. Sadi Carnot, developer of the so-called Carnot engine, was born in Paris and was educated at the Ecole Polytechnique. Remember that the Carnot engine was a mathematical theory. It was a representation of the perfect engine, the godlike engine, the engine of nature, in which all the energy is utilized. This theoretical emphasis of Carnot produced the critical insights that heat energy cannot pass from a colder to a warmer body, and that the efficiency of an engine depends upon the amount of heat that it can utilize. Basic principles in thermodynamics and today in theories of internal combustion engines. This work led to the development of what was later called the Carnot cycle, which became the basis for the second law of thermodynamics. Other examples of French engineering theorists during the early 19th century include Laplace, whose mathematical transforms provided a new pathway for solving differential equations. Laplace was a professor at the Ecole Polytechnique. Lagrange, who developed the first value theorem and what has since been known as the Lagrange equations. Fourier, developer of what's now called the Fourier series. Poisson, developer of the theory of heat transfer and of a key ratio that's used in equations today, even up through today, in equations of elasticity. Ampere, who's credited for developing fundamental theory in electricity and magnetism. Cauchy, still famous for early work in torsion and vibrations. Coriolis, who did theoretical work on moments of inertia. Prony, known for contributions to the theory of work. Navier, who made fundamental contributions to fluid mechanics. Are you getting the point here? As the historian of engineering in both France and the United States, Ada Chronakis explains, while she was doing her work, she was unable to find a single fundamental contribution to fundamental engineering science theory from Americans during the early and mid-19th century. But in contrast, the French mathematical theorists were contributing heavily to statics, to mechanics, elasticity, strength of materials, hydrodynamics, thermodynamics, theory of machines, friction, structures, vibrations, and so on. By joining the Ecole Polytechnique and either learning or developing fundamental mathematics, one was thus committing oneself to the Republic and to linking one's mind, one's body, and one's career to the state, and hence to French society and French progress. In joining the school, one was thus joining a cadre, a nucleus around which the state and society would be built. Note, for example, and I find this interesting myself, that the key date that marks a class or a cohort at the Ecole Polytechnique was not the date of entry, was the date of entry and not the date of graduation. In other words, the class of 1805 or the promotion of 1805 marks the year that the class joined the cadre, became part of the state and part of society. That's the key moment, not graduation, which is just a stepping stone in a larger career pathway linked to the state and to society.